Hey guys, and welcome back to TBS Skylabs. So today we're going to be looking at how to make an OR gate. So we've already done NOT gates, transistors, and general setup stuff. But if you're not sure, then please pop back to the beginning and see some of the earlier videos in the series. So what is an OR gate? Well, okay, so let's look at this scratch code here. So we've got two variables. We've got injured and sick. And those are Boolean variables, so they're either true or false. So if a person is sick, or if they are injured, then they should go to see the nurse. Otherwise, they should probably stay in class. So in this case, injured is true, sick is false, but that doesn't matter because as long as one of them is true, then we output a true. Forgot what I was saying there. Okay. In Python, it might look something like this. So this person is sick, but they're not injured. However, if they are sick or injured, then they should go and see the nurse. Otherwise, don't go see the nurse. Okay? It's a very similar idea. Now, how does that work inside of a circuit or a CPU or one of the other things that we've been talking about? So let's have a look. So, here's what I'm going to be using today. Assuming I can get it to stand, because I did have it set up, but now I've messed it up. Okay, so, yeah. Okay, here's what we're going to be using today. So, we've got some transistors. I'm going to try and use a pointy thing. Now, last time I took a video, I'm not sure how clear it was with the NOT gates. If it's not clear, please let me know, and I will try and remake them. So, we're going to have our transistors. Some people have asked, what kind of transistors am I using? I think these are 2N222 transistors. But basically, we're not actually caring that much at the moment. You don't want a big, one of the big blocky transistors, but most of these things are going to be fine. Most of your general transistors are going to work because we're not really doing anything that relies on specific voltages and stuff. We can deal with that another time. You're going to need some resistors. So these are, I believe, they're not 10K resistors, but they're almost 10K. So I wanted 10K resistors. I don't think I have with me in the house, but these are close enough. I'm going to need a standard resistor. Actually, I only need one, I don't need two. And that's to reduce the current coming into the LED, just with our original setup. I'm going to use a bunch of wires as well. Now, some people have asked, what's the difference between these kind of wires and these kind of wires? And in effect, absolutely nothing. These are just a bit more tidy, so they fit onto the board a bit better, and they look a bit nicer, but they're not quite as good for just making quick changes to things. So when you want to do quick changes to things, this kind of wire is much better for the LEDs. I'm also going to use two buttons this time. So notice two transistors and two buttons. Sorry, my dogs are getting loud. And we're going to try and build an OR gate. So what is an OR gate? Well, again, I don't want to step too much on your physics teacher's toes or whatever, but look at my dogs jumping at each other like crazy muppets. Oi! Dogs! Stop your nonsense. Okay, apologies. Hopefully they won't disturb you too much. If they do, sorry. So, what's an OR gate? So, as we said, when either thing is true, the other is true. So we're going to start from, and apologies, I know my drawing's a bit rubbish, but we're going to start from the positive. And again, think of it like a river. We're going to have a river that flows this way, or a canal maybe, like a canal rather than a river. So, but then that's going to split into two. Now, I think in physics this is called a parallel circuit. Please talk to physics teachers, don't trust me on these things. And then we're going to have our transistor. So our transistor is like a gate. Now, I don't know if canals make any sense to people in Nepal, but transistors are like gates or locks it would be in a canal. So basically these are stopping the water or the current of the electricity flowing through to the LED. Now I've deliberately left out the resistor here, and the aim of that is just to keep it super simple so we can kind of understand the basic concept. But there's our LED, and then we're connecting to the negative. So the idea is that if I provide some kind of basic current to either side, to either transistor, and this is going to be via buttons and stuff, then the current can still flow into the LED. Doesn't matter which one I choose because there's basically two different roads to the LED. I just have to open one of the gates or one of the transistors and it should all work. So if we called this one A and this one B, and we called our LED X, then we could make what's called a truth table. So we could have A, B, and X. And don't worry, I'm not going to ask you about the truth tables in your end of unit test or anything like that. This is just for, so you know if you do GCSE, what this is all about. So 0, 0, 0, 1, 1, 0, 1, 1 is every combination of A and B. When A is 0 and B is 0, well, so when they're both off, the current cannot flow into the LED, so it's a 0. However, if I open, I'm going to go B first, oddly enough. If I open B, then the current can flow this way into the LED, so that will produce a light on or a 1. The current can go through A, that will produce a light on or a 1. And 1, 1, well, then it can go through both, so we will also get a 1 out. So this would be the situation with my buttons. If I don't press either, I should get no light, but if I press any button or any combination of buttons, then I should get something out. And just to complete stuff, the symbol for OR gate is kind of like an arrowhead. Okay, and that's what we're going to try and build up right now. So let's break our, I know my board's really dirty, my apologies. Anyway, we are going to try and build up our little system. So we're going to start by adding in our power module. And again, this can connect to different things. Yeah, I need to check out a battery. I should do. Okay, but I'll connect to something in a moment. And I'm going to plug that onto here. Now again, remember, make sure your positives, I don't know if you can see that very well, make sure the positive side lines up with the red line and the negative sign lines up with the blue line. It worked the same reversed, but I noticed that a few people were getting confused as to when they got it the wrong way around. I find it very confusing, so it's better if you just get it right the first time. Now we're going to try adding in some transistors. Sorry guys, totally lost my my battery supply. I might have to set it up a slightly different way using the Arduino because I'm not sure where my power supplies are. Okay, so 1 sec. So let's say I just you could do it this way, perfectly fine. The first class we also used an Arduino to provide the power. It works in exactly the same way, so it's not going to change anything of the actual circuits. I'm just going to go from the ground of the 5 volts of the Arduino, which is that one there. And I'm going to connect from there into my breadboard. And I'm going to connect from the ground, which is GND, or the negative. I'm going to connect from there into the other side. Now again, traditionally we use black for negative, red for positive. Doesn't really matter, it's all good. Any wire will work, but that's the same as having this on here. Now, oh, even the light's gone on. Cool. Now, this is still quite handy because it's going to share power to my other side, I think. So that could be useful if I want to make it less busy. So, again, like I said before, we're going to need 2 transistors. So let's start by plugging those into the board, because that's probably the most important thing to understand with this one. Now, because we are doing parallel, these should not be connected in any way. These are 2 different roads into the circuit that we're making. Okay, so there are 2 different possible paths into the way. Okay, so they're not connected up. Now, just to get that going in advance, I'm going to add in a couple of buttons. Again, you could connect directly from the base or the middle leg of your transistor into the positive or negative, but buttons just make it a bit easier. And once again, as I said before, I think, really we wouldn't be using buttons in a real system. We'd either be taking the output from another logic gate, or maybe we're taking the input from a sensor. Could be from a button, perfectly possible. However, maybe, for example, if I can find one, I don't have one to hand, but maybe it might be a photoresistor, a thermistor, or one of these other possible things that's going to, once it gets above a certain level, it's going to trigger our on and off. So it doesn't necessarily have to be a manual, boom, boom, physical input. Now, from each of those, I'm going to use my bigger resistor, which I thought was about 10k. Like I said, I think these are not actually 10k's, but that doesn't matter that much. Answers on a postcard as to how big these ones are, but they're decent enough for what I want to do at present. So let's connect from there into one of my buttons. Let's go from here into one of my buttons. And apologies, I know my fingers do get in the way quite a bit here. Let's see if we can zoom in a little bit so you can see what's going on a little bit better, I hope. Okay, my stand may fall over. I think I'm pushing it off balance a little bit, but let's try and see. Okay, maybe, just maybe. Okay, it's still terrible. Okay, so I hope you can see that. I know it's not super clear, but that's going from the side of this button. It's going from there into the middle of my leftmost transistor. So let's call this one A. Okay, so from now on, when I refer to A, I'm referring to this button, excuse me, and to this transistor, more importantly. Okay, now we need to connect that itself to the positive side. I mean, it's not attaching to the board great, but it'll do. So I need to connect from here to the positive side. Now I'm going to use again these little wires, mainly because I just think they're a lot more tidy, and I know exactly where I want it to go. And if I want something I wanted to play around with, I would probably use the other kind of wire as well. Okay, so now when I press that button, it should be turning on my transistor. Fingers crossed. Doesn't feel entirely great in there. Let me just change it around and see if I can get a better, stuck in a bit more properly. Again, sorry about all the fingers. There we go. I think that's it. These resistors seem to have really thin legs. Okay, so fingers crossed, that'll work. Now I'm going to do exactly the same with my second button here. So let's go from the positive to one leg of the button. Like so. Now, that's negative. Positive to one leg of the button, like so. Again, remember, if it's in the same row, then it is connected. Okay, and that button is there. Again, it's not sticking to my board great, but it will do for now. And then I need to find my other resistor, because again, we don't want too much current going into our base of the transistor. We want to make sure that it's just the power is actually coming from the other side of the current. Okay, so let's stick that in there. And into the middle of the other transistor. There we go. Okay, so hopefully you can see that. So, and these wires are quite thin on the resistors, but hopefully you can see. So the power is coming from here into the switch or button. The button, when I press it, is going to let the current flow through this one into the base of transistor A. Button B, on the other hand, is going to take its current from here. It's going to pass it through this second resistor and into the base of transistor B. So A and B over here. Okay, so that's our like our basic control setup. Yeah, and A and B relates to these numbers over here. So off, 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 on, etc., etc. Okay, then the next system I want to build is exactly like we had before, which is going to be our basic, most standard setup that we've been doing loads of times. So we're going to plug our LED into the board. Now we can go from there to the negative with a resistor. Again, a 220 resistor, I believe. I'm going to plug from there. Let's put it over here, sorry. Plug from here. Remember, long leg is negative, positive. I'm going to connect from here into the negative outflow, okay? So I've made effectively both ends, and this is something we call decomposition in computer science. We try and break things down into little units and subunits that we can deal with much more easily. So this is my inputs, this is my output. So now I need to try and link it all together. Now how am I going to do that? I'm going to have positive power or positive current going into the transistors on both sides. So this is not like the negative. This is going to be, sorry, not like a NOT gate. This is going to be a slightly, this is going to have much more similarity to our original transistor system. Okay, so this one is getting power from here. Again, I'm not sure if power is the right word. Please find out, correct me if I am wrong. And this one's going to take its current, which is, I'm pretty sure is the correct word, from here. So I don't want to confuse people by using the wrong language, especially if your science teachers don't like it. Okay, so, and then I need to connect from the emitter, or the third leg of the transistor. So those are both going, these ones are both going into the leftmost leg of each transistor. It's identical system, more or less, for each transistor. And the outputs are going to jump from, and here's where I probably use my other wires just to make sure it works. So I've got a nice green and orange one. So I'm going to go from the rightmost leg of the transistor and into the positive of the LED. Again, hopefully it won't be too messy. That's the big trouble with these kind of wires, is they kind of get in the way of you seeing what's going on. And then I'm going to do the same on the other side. I'm going to connect from the rightmost leg of the transistor. I'm going to connect it into exactly the same row. Okay, so we're going to have 3 legs in the same row beside that LED. Yeah. Now, in theory, what's going to happen is the power can flow in any way when I turn on the correct transistor. Fingers crossed. So if I press this one, it should turn on. It does not. Oh, that one does. Okay, so what have I done wrong with this first one? Let's check. Okay, first of all, let's check the button. Oh, I think it's just the... I think it's this resistor, maybe. It's going to the right place, I believe. Because when I touch it, look, it picks up on my human electricity, but it doesn't seem to be working with this button. Let me turn the button around and see if that does something better. Oh yeah, there we go. See, one of my legs was bent, so it wasn't actually connected properly. It's probably why it's not sticking to the board really well. We've had loads of trouble with buttons. They just... Yay! Okay, so, again, going back to my truth table over here. 0, 0, which is currently it is, provides us a 0 output. 0, 1. What have I done? Now I broke the other one in the process. Hang on. 0, 1. So 0, 0, 0, 0, 1 is a 1. 1, 0 is a 1. And 1, 1 is also a 1. Okay, so we've been able to manage with 2 transistors to make an OR gate. And hopefully, I hope you guys can see that. I'm aware these circuits are getting busier and busier. Just try your best. But just the main thing to remember is that the The transistor setup's identical. The only thing that's really changing is you're providing 2 transistors into the LED and out. Okie doke. Now, one thing I would probably suggest at this point is maybe you don't want to be taking these apart, because we're going to later on try and combine not and or together to start doing stuff. And hopefully, if you're able to have different breadboards and different setups, it'd be much easier just to plug it all in together. Okay, thank you very much, and I will see you next time.